So I'll use this opportunity to talk about monsoon and El Nino again. This we had seen before and said only about 15% of the monsoon droughts are explained by El Nino. So there is our El Nino shown with the wind anomalies also in this case. And this pattern we didn't talk about. We only talked about what happens here. And we talked about the cooling here. So the Walker cell perturbation tends to produce this kind of pattern as well in most El Niños, especially sometimes these winds get very strong and there is an upwelling here. Remember, the normal conditions is that the Indian Ocean is warm here pretty much throughout the year, and the upwelling is fairly weak in the summer months because there is no trade wind and Ekman divergence on the equator here, but there is some upwelling here because of the monsoonal forcing. So it's very opposite to the Pacific and Atlantic Oceans. Nonetheless, people like Dak Chen from Zhuhai have argued that this is actually a Indo-Pacific tripole, and we shouldn't think of just El Nino, but we should think of what happens to this whole region. I would like the idea, except we don't know still what to do with that in terms of improving our understanding or predictions and so on and so forth. Without going into further details, this is what I refer to as the Indian Ocean dipole, this kind of pattern with cold sea surface temperature anomalies here and slightly warm sea surface temperature anomalies here. There is some arguments that this also affects the monsoon, but the other thing to note is that the Indian Ocean is much smaller than the Pacific Ocean, so the adjustments that we talked about in terms of the Bjerknes feedback and so on are very weak here, and this El Nino, when it happens, which is very rare, lasts only for 3 months, and it happens during September, October, November. Remember, this is peaking in December, January, February. This is happening in June, July, August, September, the monsoon rainfall, and this is happening in September, October, November. So it's not always clear whether this is caused by monsoon or by El Nino, or whether this is affecting the monsoon and affecting the El Nino. There is some evidence that when this happens, the El Nino tends to get stronger as well, but both may be related to the perturbation of the convection over here in the Western Pacific. So lots of questions remain. Nonetheless, because of the smaller zonal extent in the Indian and Atlantic Oceans, there is a zonal mode of variability, a east-west mode of variability that seems to be again forced by the West Pacific convection, which is a monster with 5 meters of rain per year, that may be creating these El Nino-like modes which are much shorter lived. So there is the Atlantic Nino, which is showing warm and cold anomalies. So this is the Atlantic Niña, this is the Atlantic Niño, and this seems to have a strong effect on the Indian monsoon as well. This is looking at the difference in the Indian monsoon for a warm this is excess rain. So between a cold event and a warm event, so the difference between Atlantic Niña and Atlantic Niño, just like La Niña, Atlantic Niña seems to bring excess rain over parts of India, and the Atlantic Niño tends to reduce the rainfall over India. So obviously, if you look at the ITCZ, which is the global link and moving back and forth, maybe you can think that all these things are related somehow through the ITCZ. But again, we don't know whether the ITCZ is a response to these things, or it is a driver, or it's a feedback between all of these things. So again, lots of questions remain. This is a nice work by our good friend Roxy Matthew Cole at the Indian Institute of Tropical Meteorology, who showed that the monsoon has dropped in seasonal totals over the last several decades by about 10% as the Indian Ocean has warmed. So Indian Ocean warming is associated with the decreasing rainfall, which is counterintuitive, because if you think about the land ocean heating, you think warmer ocean would reduce the pressure and give you stronger monsoon. It turns out, presumably maybe because of the increased pollution and aerosol, the land is not warming as much as it should under global warming despite its low heat capacity, and that's presumably keeping the land from warming faster than the ocean, and hence reducing the land-ocean thermal contrast and giving us this decreasing rainfall. So there is a decreasing rainfall but increasing extreme events. And Roxy's other paper also shows that the rainfall's extremes are now becoming more widespread. They are occurring on scales of 10,000 square kilometers. Okay, floods every year cause enormous damage over the Indian region. So here is the damage shown in terms of number of deaths and so on for, I think these are 2 different years, 2019 and 2018, but nonetheless you can see that here is a widespread flood, for example. This is extreme rainfall event over a large region as well as on the coastal cities. So Kerala and Mumbai, for example, are getting inundated a lot now. Okay. The story is a little bit more complicated. The onset, which happens around June 1st, okay, this is showing onset days with respect to June 1st, seems to be arriving a few days later after the mid-1970s, where we said the global warming seems to have accelerated. The withdrawal seems to have been occurring a little bit earlier, which means the later onset. Earlier withdrawal means the season is squeezed and made shorter. And the wave-like features that bring the rainfall from the warm ocean onto land and create these active break cycles are slowing down. So this is showing a relation of the propagating features from the equatorial region onto land, and arguing that the speeds were faster before, but now they are slowing down. In general, all the cyclones over the globe are also moving slower. These are cyclonic features. Maybe the same processes are occurring, but actually we don't understand that very well. So basically the onset, length of the rainy season, withdrawal, rainfall distribution, active break periods, duration, intensity, and the propagating features are all changing, and looks like all aspects of monsoon are being affected by global warming, as well as more specifically the ocean warming, and maybe the lack of warming over land because of pollution. Now there are some arguments that the land warming has begun to pick up, and that the monsoon is recovering. So the drop in the monsoon is not happening anymore. This is the tricky part about separating trends from natural variability. What if the monsoon has a 40-year time scale? So you saw a 40-year drop and then you're going to go back up. So this is very tricky to separate what is caused by global warming and what is happening naturally. But we won't go into those details here. Okay?